Bismillahirrahmanirrahim. Assalamualaikum and good evening, everyone. My name is Ammar Harith bin Muhammad Hafifi. My metric number is F25A1557, and I are the leader for this group. So today, I will present my project entitled on oil palm yield modeling via calculus. The purpose of this project is to apply calculus concept in agrotechnology by analyzing oil palm yield growth patterns. We use mathematical modeling and data type to understand how production changes over time. First, let us discuss the problem statement. In Malaysia, agrotechnology maximizing fresh food bunch or FFB yield per hectare is very important for sustainable palm oil product. According to historical data from the Malaysian Palm Oil Board or MAPOB, oil palm production follows a sigmoidal or S-shaped growth patterns. The challenge is not only determine the total yield but also identify the year when production growth reach its maximum point. This helps plantation managers optimize fertilizers schedule and labor planning. To solve these problems, we use a logistic growth functions. As you can see here, the calculative yield function is f. So in this question, M represent the maximum yield capacity which is 25 tons per hectare. K is the growth rate constant which is 0.25. X0 is the inflection year which is 8 years. X presents 3H. This mathematical model creates an S-shaped curve which reflects the real biological growth. And then derivative analysis. To calculate the instantaneous rate of change, we use the first derivative. As you can see at the lower, the derivative tells us how fast the yield change at the particular times. Instead of only observing total production, the derivative allowed us to measure production velocity. Now, we're going to talk about yield curve simulation. Now we move to the graph. The green line represent cumulative yield, while the orange lines represents growth velocity. At year 11, as shown in the graph, the cumulative yield is approximately 16.98 tons per hectare, while the growth velocity is 1.36 tons per hectare per year. This indicates the yield is still increasing, although its growth rate began to slow down after reaching its peak. Lastly, for the conclusion, calculus can be effectively applied in agriculture by using logistic function and we can predict oil palm growth patterns and identify the optimal product periods. This can help improve increasing efficiency and support sustainable agriculture development. Thank you for the attention. I are ready for any question. I will give to my colleague.
Hi everyone. My name is Noor Fatin Athirah Binti Ranizam. My metric number is 1531. So today I will be presenting about agri-maths, specifically how we use mathematical derivative to optimize harum manis mango cultivation. Okay, so the main problem for harum manis famous is guessing the exact maturity of the fruit. If they harvest too early, the mangoes are sour. If they harvest too late, the fruit spoils. Relying on guesswork causes high financial loss. So we need math to calculate the exact growth rate. So, why is this study important? Firstly, higher profit. Harum manis is a premium fruit. Better quality means higher income for local farmers. Secondly, save resources. Farmers will know the exact time to apply fertilizer and water, preventing. Thirdly, modern farming. It changed traditional farming into smart data-driven agriculture. So, as you guys can see, the first point is this shows the instantaneous growth rate. It tells us exactly how many grams the mango is growing per week at this very moment. So the next point, the growth acceleration. This helps us find the inflection point, the exact moment the mango stop growing in size and start developing its sweetness. The final point is the most important. When the growth rate equals 0, the fruit has reached its maximum size. This mathematically pinpoints the perfect harvest window. So, lastly, my recommendation to make this HTML page much better is to add an interactive slider using charts. Instead of just reading boring text, user can move a slider across a timeline as they slide dynamically. When it hits the perfect harvest day, a green alert pops up saying optimal harvest day reached. This makes the web page much more user-friendly for farmers. That's all from me. Thank you.
Hello everyone, my name is Noor Aqeelah Binti Aziz and I am from SFH. My metric number is F25A 17 and 64. Today, I would like to talk about my project on Malaysian aquaculture, specifically focusing on tilapia farming. Right now, our local farmers face a huge problem. They struggle to manage resources and track how fast their species grow. Traditional farming relies too much on guesswork. Without proper monitoring, it leads to bad feeding schedules, poor water quality, and sudden drops in harvest yields. So, to solve this, let's take a look at this interactive HTML page. Here, we integrate mathematics into this biological system. We use a cumulative growth function to model the overall weight of the tilapia fish over time. And then we use derivatives. By differentiating this cumulative function, we get a new function that represents the instantaneous growth rate. Knowing this exact rate is a game changer. It allows us to identify the exact moment of peak growth acceleration. As you can see on this graph, the curve peaks right here. This peak shows the highest growth rate. It tells the farmer the exact time when the species needs optimal nutrition and maximum oxygenation. After this peak, the growth rate starts to slow down, so farmers can adjust their feeding and resources perfectly. To improve this project, I recommend adding a light and dark damp toggle. More importantly, we want to allow farmers to input their own plant data to generate custom growth graph on the spot. In conclusion, using made in aquaculture remove guesswork, save money, and help secure our food supply. That's all from me, and thank you for your time.
Hello, my name is Alwani. My matric number is F2531536. I will explain agrotech derivative simulation. For introduction, is agrotech derivative simulation is an application that demonstrates how the mathematical concept of derivative can be applied in agriculture. The simulation helps user visually how change in factors such as time, growth rate, or resources uses affect crop development and productivity. About objective, the main objective is to help understand the relationship between variable and crop growth. To provide an interactive learning experience for students studying calculus and agriculture technology. And last, to demonstrate how mathematics can be used to solve practical problems in agriculture. Untuk graf tu pula kita tengok sini je lah. For year 1, it's minimal because the seed have just been planted and are beginning to germinate. Day 2, the growth start to increase as the seedling emerge and begin absorbing. Day 3, the growth rates become faster, showing healthy development. Day 4, rapid growth occurs due to favorable environmental conditions such as sufficient sunlight, water, and nutrients. Day 5, growth continues to increase and may reach its highest rate during this stage. Day 6, the growth rate begins to slow down as the plants approach maturity. Day 7, growth becomes stable, indicating that the fruits are nearing full development and they approach zero. So, application in agriculture is the simulation demonstrate how derivative can be used to monitor growth rates, predict future agriculture output, optimize the use of fertilizer and irrigation, identify rate of measure growth, and last, support data-driven decision making in the farming. So the conclusion is the agriculture derivative simulation is an educational agriculture technology. By using to analyze rate of change, the simulation helps user better understand group patterns and demonstrate the importance of climate in modern agriculture. So, important of the project is the derivative simulation is important because it bridges the gap between practical mathematics and real-world agriculture application. It enables students to understand how derivative can be used to analyze and predict growth patterns, making mathematical concept more meaningful and practical. The process promotes the integration of technology and agriculture. Furthermore, it helps develop critical thinking, analytical skill, and data-driven decision making that are visible in agriculture environment. That's all for me. Thank you.